Thank you all for attending this communication entitled Headspace Solid Phase Microextraction for the Evaluation of Paper as Eucalyptus Essential Oil Carrier. Authored by Silvia Gramacho, Dina Murtinho, Artur Valente, and myself. It involves not only the study of paper and modified paper as carrier for this essential oil, but also a certain strategy of functionalization of this material to confer more protection, and this is going to be key, to the compounds present in eucalyptus essential oil, both from leaves or from wood. This work was carried out under the project Impactus, as shown, funded by Portugal 2020 through European Regional Development Fund. And the outline of the presentation looks like this. We are going to start by exposing some background on paper with essential oils and why to do that, what we try to do, and how to achieve it. So there's undeniable interest in paper with essential oils, as we will prove, mainly because of their antioxidant and antimicrobial properties that may confer some long-lasting protection to paper itself. One example of it is Real Aerosol's packaged paper, which contains cinnamon essential oil. This is quite recent, with a patent already granted, but yet not commercially available as far as I know. Another example we can mention is wrapping paper coated with grapefruit seed extract. In these cases, cinnamon and grapefruit, the main constituents of these essential oils are phenols, either monophenols or polyphenols. However, a new problem arises if, instead of phenolic compounds, we try to put on paper Eucalyptus globulus essential oil, which consists mainly of terpenic compounds. It's worth the pain because of these properties, but it comes with a drawback, which is that terpenes are highly volatile in water and they evaporate along with the solvent after sheet forming or whatever process that requires paper drying. Some approach for this is entrapping the terpenes in a cross-linked networks, in this case of cellulose, in the publication whose DOI is given, but we are going to try a different strategy. An approach based on the use of cyclodextrins, cyclic oligosaccharides with hydrophobic cavity and hydrophilic exterior. This approach has already been tried in the past on paper, either by sheet forming or once the paper is formed. Here we wish to suggest coating, which is less harmful for cellulosic fibers than using high temperatures when the paper is already formed, and it minimizes the losses caused by filtering when the sheet is formed. So in this case, we are going to produce a cyclodextrin functionalized polysaccharide, which, according to our needs, is going to entrap the hydrophobic compounds present in essential oils from eucalyptus. We hypothesize that this way they could be protected from fast release, UV degradation, and oxidation. In this work, we are going to test only the protection from fast release, from losses to air. The whole experimental process consists of synthesis, paper coating, headspace solid phase microextraction, and gas chromatography mass spectrometry. As long as we use a cross-linking agent, we will take the risk of cross-linking between polymer chains. So we proceeded with a two-phase esterification. First, attaching this polyacid, this cross-linker, butan tetracarboxylic acid, to beta-cyclodextrin in solid state at 140 degrees. And only then, once we have this derivative, we grafted beta-cyclodextrin with cross-linked moieties onto starch, also in an oven, solid state, and this time 160 degrees. Finally, once we have this modified starch, we can use it to coat paper. The headspace solid phase microextraction follows the scheme presented here. Briefly, we cut a paper sample of 30 square centimeters, roughly 260 milligrams, and place it into a hermetically sealed chamber. A polymethylsiloxane carboxane divinylbenzene fiber goes through the septum and remains exposed to headspace for a certain period of time. Then, the fiber is injected in the column of the chromatograph, attached to a selective mass detector, which allows for qualitative analysis. For instance, this spectrum corresponds to eucalyptol. For quantitative purposes, we use fluorobenzene. When it comes to the results, we are going to show the composition of essential oils from leaves and wood, and to study their release from paper. On one hand, the oil from the leaves consists mainly of, as we'll see, eucalyptol, pinene, particularly alpha-pinene, sesquiterpenes, aromandendrine, limonene, and other compounds of low molecular weight. On the other hand, in the extract from wood, low molecular weight compounds like monoterpenes such alpha-pinene and alpha-terpineol and alkylyptol are found in lesser fraction. In contrast, this oil is rich in aromandendrine, a sesquiterpene, and especially in sesquiterpenoids such as globulol and epiglobulol. It also contains minor fractions of fatty acid esters and hydrocarbons. Therefore, the oil from leaves consists almost entirely of volatile terpenic compounds, and the one from wood has this variety. We are going to take advantage of this variety, as I'm going to explain now. Now, when we expose paper loaded with eucalyptol, only that, not even the standard in this case, we observe zero order kinetics before halting, possibly due to fiber saturation. The correlation coefficient, taking in account these few first points, is of 0.39, so the linear fit is obvious. But this trend, and we didn't expect otherwise, this trend is not observed when tracking a compound in a mixture, such as the case of these essential oils. Hence, the change in composition is what is going to allow us to get reliable results. We see how, with time, vapors are increasingly more concentrated in high molecular weight compounds, meaning that low molecular weight compounds, monoterpenes, monoterpenoids, are preferentially lost during the first hours or even the first days. Now, if we try this with leaves oil, we'd see little difference with time in composition. This is why we choose to evaluate paper loaded with the essential oil from wood. And finally, we get to the slide that contains the most important piece of information. When conventionally coated paper is compared to cyclodextrin containing paper, in both cases with the same amount of eucalyptus essential oil, I recall, from wood. Both kinds of paper were exposed to air at room temperature for a week, and during that time we expected that most volatile compounds, monoterpenes, monoterpenoids, would be lost, but the question is, to what extent? And this table that I'm going to show now displays how of eucalyptol, terpineol, and alpha-pinene we don't have anything left. I mean, this is below the limit of detection of the chromatograph. After 1 week of exposure, every single light compound was lost. Of course, in the case of paper with cyclodextrins, they are in lower quantities, but they are still there in important amounts, I would say. Maybe not pinene which is more volatile, even more volatile than monoterpenes with oxygen, but at least, even for alpha-pinene, there's 0.013 milligrams adsorbent on fiber. And this table is what justifies the success of this work and what supports our hypothesis. All low molecular weight compounds were lost in the case of paper without cyclodextrins. Of course, starch itself offers some protection due to the helicoidal structure of hemylose, but 1 week is more than enough to get rid of all monoterpenes and all monoterpenoids. We need cyclodextrins to ensure long-lasting protection. This graph is going to give us a more detailed view. In all cases, after 1 week, fibers are more concentrated in globulol, in general in heavy compounds, and obviously less in low molecular weight compounds. But the difference between cyclodextrin containing paper and unmodified paper is that regardless if we use ethanol or not to extract, we don't get any eucalyptol in the case of conventional coatings, and we get significant amounts in the case of cyclodextrin functionalized paper. Actually, that's a good conclusion, but we are going to sum it up. In short, the process of functionalization paper with cyclodextrins itself is simple, quite easy, facile, but some drawbacks come from the synthesis part. It needs high temperatures, which may cause degradation, and the use of sodium hypophosphite, which is under question in environmental terms. Yet it confers effective protection as shown to monoterpenes and monoterpenoids, which otherwise would be mostly lost along with water during paper drying, or at most during a week of paper exposure to air. Plus, it does not require any surfactant or organic solvent, even though these compounds are hydrophobic. Thank you again for attending this presentation. I will address any issue that is raised.
Good afternoon, everyone. My name is Fábio Silva. I'm a PhD student from the University of Aguado, and I'm going to talk about the development of new photopolymerizable paper coating formulations based on tung oil for sustainable paper packaging. Starting with the outline, I'll do a brief introduction to the work objective and problematic, following by the methodology used for its execution, going through some preliminary results already obtained, and finishing with some major conclusions. Paper is a common and cheap substrate with some characteristics such as biodegradability, recyclability, lightweight, and sustainability, which justify its wide application as a commodity, especially for packaging. However, in order to paper to be applied as a packaging material, its water and gas barrier needs to be improved, which is usually done by the application of non-renewable paper coatings obtained from crude oil. Although these coatings are very effective, they rob paper from their sustainable characteristics. So, in order to obtain truly sustainable paper packaging, we need to develop renewable paper coatings. And the materials to do so can be found in biomass. So, from biomass, we already obtained paper and some coatings already applied, such as starch-based coatings and waxes, for example. However, there's one more material that's caught our attention, which is tung oil. Tung oil has good film-forming properties, is biodegradable, and most important, it's photopolymerizable, which permits us to use the photopolymerization technique. It is of easy implementation, permits good control or better control of the formulation's rheology, avoiding problems in the coating application, and also it permits solventless formulations, avoiding use of organic solvents and therefore the solvents that can produce volatile organic components. With these three elements, paper coatings or renewable coatings and photopolymerization, we hope to be one step closer to develop truly sustainable paper packaging. So, regarding the methodology used in this work, we start by developing 4 Tecnicelpa-based formulations. These formulations were all applied to 2 types of paper, base paper and commercial paper, where the major difference between these papers is the exosurface sizing that commercial paper has. Also, we studied the increase of the coating pickup by applying an increasing number of coating layers. All of the coatings were applied through rod coating. After the sample preparation, they were irradiated at 3 watts per square centimeter during 15 minutes. And after its conditioning in a room with humidity and temperature controls, they were fully characterized. The pickup was calculated, FTYR ATR spectra were taken, as well as SEM micrographs, and the optical, mechanical, and hydrophobic properties were also evaluated. Starting with the pickup of the coated samples, it can be seen that a low variability between samples, which shows the good reproducibility of the coating technique, rod coating. Also, the increased number of layers increase the pickup of the coating as expected. SEM micrographs were taken for all the samples, the coated samples. Where compared with the non-coated paper, we can see the presence of the coating, although not as a continuous film, unfortunately. Through FTYR-ATR, we evaluated the chemical structure of the paper-coated surface. Where using the non-coated paper as backgrounds, we could identify the characteristic peaks of tungsten in all papers, in the surface of all coated papers. Regarding the optical properties of the coated papers, it was evaluated the whiteness, the gloss, and light scattering coefficient, which is closely related with the opacity of the paper. Starting with the whiteness, the presence of the coating had a detrimental effect on the whiteness values for both papers. This detrimental effect was the same for all the formulations. However, the pickup increase had an effect just on the base paper whiteness values, while on the commercial paper the values maintained the same that for just one layer. Regarding the gloss values, once again, the presence of coating had a detrimental effect for both papers, and this effect was the same for all the formulations. However, in this case, the pickup increase had an effect on both papers, reducing the gloss values even further. The light scattering coefficient was the most affected property, where just one layer had a major reducing effect in these values. For all the formulations, the effect was the same, and for both papers, as you can see. Also, the pickup increase had a major effect, an even higher effect on the light scattering coefficient reduction, where for two layers it reduces even further, and for 3 layers even more. The surface rugosity and air barrier properties of the coated paper were also evaluated. through using Benston and the Curly tests. The Benston permits us to infer regarding the surface rugosity of the coated papers, and when compared with non-coated papers, we can see that all the formulations increase the rugosity of the papers. However, more for the base paper than for the commercial one, mostly because of the extra surface sizing that commercial paper has. The, the increase in the pickup also has a major effect or a higher effect in the base paper than the commercial paper. For the Gurley values or the air barrier properties, we see a slight increase for both papers and all the formulations. However, with the increasing number of layers, or with increasing coating pickup, we see that the curly is highly effective, increasing much more with higher number of layers, especially for the base paper. The mechanical properties were also evaluated. More specifically, the tensile resistance and the burst strength. Regarding the tensile resistance, we can see a slight increase on this property, both for machine direction and the counter machine direction. And with the pickup increase not having a major effect, just a slight increase. Regarding the burst strength, the application of coating has also a slight increase, but with the increasing number of layers or the increasing pickup, we see that the burst strength of the coated papers is much more increased compared with non-coated papers. Last but not least, the hydrophobic properties were evaluated by measuring the contact angle and the COV values of the coated papers. Regarding the contact angle, we see an increase in contact angle of coated papers for all the formulations and both papers. However, this is not changed with increasing number of layers. For the COV values, we see a decrease for all of them, for all the formulations and all the papers. And with the increasing number of layers, or with the increased pickup, coating pickup, we see a reduction of the COV values even more. To be noted, for the F3 and F4 formulation, we see that impact it's less than for F1 or F2. This is worth of mention, and to take into account when evaluating the constitution of the formulation, meaning that there's something in this two formulation that need to be changed in order to having the same effect at F1 and F2. So to finish with some conclusions, we'll start with the application of Tungol-based formulation was successful with great reproducibility and identified by FTYR and SAM. Regarding its impact in the paper properties, the optical properties of the coated papers were reduced for all papers and all formulations. However, the mechanical properties, air barrier properties, and hydrophobic properties were increased, proving that this kind of coatings have potential to be used for the development of new sustainable paper packaging. I would like to thank my supervisors and all my colleagues on Biopol for Fun Work Lab. Also, I would like to thank the University of Aveiro, Raiz, and the Navigator Company for all their support. Thank you very much for your attention and feel free to ask any question.
Hi, my name is Paulo Dias and I will present our work entitled Efficient Experimental Protocol for Multifactor Modeling and Wide-Range Prediction of Mechanical and Dimensional Properties of Paper. This presentation is organized as follows. First, we will present the background and goals of this work. Then, we will briefly describe the methodology developed and the experimental plan followed to apply and test the methodology. The results obtained are subsequently shown, and, finally, the main conclusions of this work are presented. Paper quality parameters, such as the mechanical and dimensional properties, should meet increasingly tight specifications to guarantee the satisfaction of customers and maintain the competitive position of paper-producing companies. These properties are typically evaluated by process monitoring activities, including end-of-line testing. In this reactive approach, the faults are detected after occurrence, leading to post-factum interventions in the process to correct the problems. Although an important approach, an anticipatory and proactive methodology should also be implemented to improve the quality of the produced paper. In this case, the properties should be inferred by testing the pulp, allowing prediction of potential problems and, therefore, permitting the timely implementation of preventive measures to avoid faults and to optimize the process. However, laboratory tests currently applied to evaluate pulps provide limited information regarding the potential to infer its behavior under real production conditions. The main reason for such limitation lies in the usual absence from the experimental protocols of key effects such as fiber orientation and drying restraints. Therefore, the goal of this work is to develop a robust and theoretical driven methodology to infer relevant mechanical and dimensional properties of paper produced from a given furnace using a minimum number of experiments and incorporating the main contributing factors. We will now present briefly the methodology developed in this work. The main active factors largely responsible for the mechanical and dimensional properties of paper are pulp furnish, fiber orientation, internal stresses, density, and relative humidity and temperature. In this work, three of these factors are blocked, namely the pulp furnish, density, and temperature and relative humidity. Therefore, the main factors considered in this study are the fiber orientation and the internal stresses. It should be mentioned that the internal stresses are introduced in the paper by the restraints applied during the drying phase. The proposed methodology is based on previous studies, namely, under similar drying restraints and density levels, theoretical derivations predict the isotropic properties to be similar to the geometric mean of anisotropic sheets for different levels of fiber anisotropy, in line with experimental studies in the literature. Therefore, measurements of free and restricted dry isotropic sheets are combined with theoretical energy-based relationships to infer properties of anisotropic sheets for the expected level of fiber orientation and drying restraints in the paper machine. In this work, the elastic properties, namely the tensile stiffness index or TSI, were predicted applying the independent Perkins model or IPM model. This model assumes the independence of elastic properties in the given direction to the applied drying constraints in an orthogonal in-plane direction, in line with experimental data found in the literature. The dimensional properties were represented by the coefficient of hygroexpansion, expansion, which measures the deformation occurred between a relative humidity of 33 and 66%. An empirical model, the ICM model, was used to predict the coefficient of hygroexpansion. expansion. The proposed methodology was applied and tested by implementing the following experimental plan. Isotropic sheets prepared in an unsheet former for two drying conditions free and restricted, were combined with the proposed models to predict the TSI and the coefficient of Figure expansion of anisotropic sheets. The anisotropic sheets were prepared in a dynamic former for 3 levels of fiber anisotropy and for 2 levels of drying conditions, free and restricted. We will now present the main results obtained in this work. In these graphs, one can observe the results obtained of the TSI and of the coefficient of Figure expansion for both types of sheets, isotropic and anisotropic. First, we should mention that the TSI values of freely dried sheets in CD were probably below the detection limit of the tensile testing equipment used and should not be trusted. Thus, with the exception of the TSI result for the freely dried sheets, the geometric mean of both properties, TSI and coefficient of Figure expansion, were shown to depend predominantly of the applied drying conditions, being apparently invariant for the considered levels of fiber anisotropy. Additionally, the geometric means were found to match the isotropic results. These results are in line with previous studies confirming the general validity of the experimental procedure following this work. The invariance of the geometric mean can also be observed in the following graphs, which represent the variation of the properties with fiber anisotropy levels. Therefore, the models can be applied and tested. First, we combined the isotropic results with the independent Perkins model to predict the TSI values of the anisotropic sheets. As mentioned before, the TSI values obtained for freely dried sheets in CD are probably below the detection limit of the equipment and should not be taken into account in the analysis. The model accurately predicted the TSI values of restricted dried anisotropic sheets in the two directions, MD and CD, presenting a relative deviation from the experimental values ranging from 0.5 to 10%. The model could also predict to a certain degree the TSI values of anisotropic sheets dried freely in MD, presenting a relative deviation of around 20%. The reason for this higher deviation is probably due to errors related to the measurement of the strain accumulated during drying from freely dried sheets. Nevertheless, the IPM model presented in general good prediction of the experimental values using minimum experimental work. Similarly to the IPM model, we also combined the isotropic results with the empirical-based ECM model to predict the coefficient of Figure expansion of the anisotropic sheets. The model was shown to infer the experimental data properly, presenting relative deviation values ranging from 5 to 15%. However, the model presented higher prediction errors for sheets dried freely in CD, with relative deviations reaching 25 to 30%. As with the IPM model, these higher deviations are probably due to errors related to the measurement of the strain accumulated during drying for freely dried sheets. Overall, good prediction of the experimental values was obtained using minimum experimental work, confirming the potential of the proposed methodology. Besides the two directions, MD and CD, the ECM model can also be applied to predict the coefficient of Figure expansion for all the directions theta. The following polar diagrams present the values of the coefficient of Figure expansion predicted by the ECM model for all directions theta for the 3 levels of fiber anisotropy considered. The observation of these graphs allows to confirm the potential of the model to infer the experimental results. We will now present the main conclusions obtained for this work. We developed a strategy based on accumulated empirical evidence and theoretical results that successfully predicts the elastic and dimensional properties of paper prepared from a given furnished pulp. The strategy combines isotropic results with theoretical energy-based relationships to infer properties of anisotropic sheets under a variety of drying conditions. The application of this strategy requires minimum experimental work, guaranteeing a more complete characterization of paper properties. Additionally, the strategy allows the implementation of preventive measures to avoid potential quality problems. Finally, we would like to acknowledge the support received to develop this work.
So, hello everybody. Good afternoon. Boa tarde.
Good afternoon.
Bom dia.
Good
Buenos
afternoon.
dias. For all our colleagues around Portugal, around Europe, and also around the Americas. So, welcome, and I'm glad to be here moderating this session. We have three very interesting presentations related to different aspects of the valorization of paper and different angles. So we have one paper presented by Roberto related to working with eucalyptus essential oil. A very interesting presentation. We already have a couple of questions here on the pipeline. Then we also have another application on the paper packaging by using tung oil for paper coating. Also, very interesting presentation here from Fábio and from Siseco. And then finally, we have a more of a mathematical modeling application for inferring paper properties coming from Paulo Dias from University of Coimbra. So I'm just scrolling here for the questions. Again, we have here a couple already. Maybe starting with Fábio, and I think from before I go into the devil in details, just maybe for the sake of the overall audience that are probably not more versed in this type of tongue oil applications, just if you can give a brief explanation, where does this tongue oil come from, where they are produced, and how could they be sourced coming for the application that you mentioned on the sustainable paper packaging? That would be interesting to hear from you.
Excuse me, you want me to explain regarding
just to make it clear for everyone, tongue oil, what is tongue oil, and where this idea firstly originated from?
tung oil, it's obtained from tree, and that is called Chinese tree. Tung oil is also commonly known by Chinese oil, and it's widely used for applications in wood to wood coating, and the idea was basically we wanted to develop a formulation that could provide hydrophobicity to paper, and the components for the formulation could be provided from biomass to maintain or develop a coating that was from a sustainable source to tackle a little bit the crude oil necessity, and that the final coating could be biodegradable, maintaining the sustainability that paper can provide for packaging. Regarding the application, we wanted something for packaging. More specifically, it really depends on the final properties, since we are starting to optimizing the final formulation.
Okay, so thank you for that clarification. Now we have a very interesting question here from the other, also for you, Fábio. So what kind of interaction are you expecting between oil and cellulosic surface while exposing the UV light on coated papers?
Well, I'm not expecting much of an interaction in terms of the formation of chemical bonds, if that is what the audience were implying. For this specific case of Tungwell, at least, because of the way that Tungwell forms bonds, or the way that Tungwell's cure through oxidative processes with oxygen. So I don't believe that there is some kind of interaction with specifically with the Tungwell and the cellulose fibers, only between the Tungwell molecules, where they form a cross link, improving the hydrophobic properties in this case.
Okay, Fábio, thank you for that as well. Now turning a bit to Roberto, and also for his nice presentation regarding the eucalyptus essential oil. And my first question, also more of a clarification for me, as I'm not fully versed or versatile on the application itself. So also because it was not fully clear for me, question is really, what was the objective of your work by using, the paper as carrier of essential oils? Do you want to give functionalization to the paper for a certain type of application, or is it something else that you're looking for with your development work?
I had to say originally, and this is why we were using office paper instead of packaging paper, as I for example mentioned the example of Relesa Repsol's packaging paper, which is very useful. But originally, first we wanted to give long-lasting smell to paper, like pleasant smell. We got such a slow release that smell was not possible, that we couldn't get this eucalyptus-like minty smell. So we turned to antioxidant properties that are actually more useful for example, food packaging, antioxidant, antimicrobial. These are actually more useful for packaging, but anyway we use base paper, normal paper, so the same can apply to packaging paper, so it can be exported to that topic too.
Okay, so basically, when you say that you didn't get the release that you wanted, basically it was too quick than the one you were expecting to begin with.
Yes, because the first thing we tried was long-lasting aroma, like to be used in office paper, printing paper. I mean, we didn't achieve that, but we didn't. And first, we thought experiments hadn't been successful, but as we did these tests with chromatography, we saw that the compounds from the essential oil were actually there. It was only that the release was so slow that of course there was no way it could smell, and even 1 week later the compounds are still there. So we changed the focus. Instead of smelling paper, it had to be just like a drug delivery system, And when we talk about this essential oil, well, you could also replace it with any antibiotics, drugs. I think it's quite versatile.
Okay. So again, very, very interesting. I just have here a kind of a technical question, because as I understand it from your side, this is a lot of these components are very volatile. So I guess that's a problem even with the kind of derivatization that you've made with the cyclodextrin. But would it make any sense to, if you want to remain that components active on the paper, basically using some sort of pressure system so that you don't have that release? Of course, it's a different type of paper probably, but probably different applications might be worthwhile.
Yes, yes, that's another strategy.
Okay, so kind of final question before I go into Paulo and do another round. So I have here a question for Roberto, more kind of technical driven from the audience. Basically, how do you characterize the starch CD and cellulose CD, and which one do you think is good for essential oils?
Yeah. The characterization can be a little bit tricky because both starch and these polymers, starch, cellulose, and this oligosaccharide cyclodextrin, have exactly the same functional groups, the same composition, carbon, hydrogen, oxygen, and the same empirical formulae, right? So there is no way by elementary analysis, there was no way by FTR. By FTR, we can only distinguish the crosslinker. The crosslinker. We actually see the ester bonds that were created. We can dissolve this in D2O with also NaOD and find ester bond. But at the end of the day, for the proportion or the ratio of cyclodextrin to polymer, we have to rely on quite indirect measurements like weight gain, gravimetry, and phenolphthalein, the suppression, the quenching of phenolphthalein adsorption, which forms a one-to-one complex with cyclodextrin. So basically, phenolphthalein absorption followed by ultraviolet absorption spectrum. FTR just for qualitative purposes. NMR, again, qualitative purposes. Microscopy to see the effect on morphology. And that would be it, basically.
Okay, Roberto, thank you for that explanation. Now turning a bit on the mathematical part of the paper. So, Paulo, I guess that you're not the chemist here as the other two speakers, but also interesting presentation from your side. Coming from my side, I think very interesting question I have in my mind is really to ask you, how do you think you could apply your mathematical model to a real life paper machine? I think that's a question that you might hear a lot. But I think it's an interesting question to be done, because the model is quite interesting. You have good results, good fit to the model. But take in consideration that you have fixed certain conditions, like temperature, humidity, and furnish. And basically, you have here the drying conditions as the main component. Do you think that will be easy to apply this to a real-life paper mill experiment? And if so,
It has the
how
potential.
would you?
Okay, thank you. Thank you for your question. Okay, it has the potential to be used, and to be used, we need to guarantee that we can prepare isotropic sheets using the same drying conditions or very similar drying conditions to the ones that were applied in the paper machine. So we need to guarantee that more or less the pressing conditions. So we need to get a similar density for the sheets. We need to use exactly the same pulp or mixture, and in that case, it could be used. Then we need to know what are the predictable drying conditions at the paper machine, and what is the predictable fiber orientation at the paper machine. For example, those two factors, usually we have information what is the typical in a given paper machine. So answering directly, it can be applied, yes, if we can guarantee similar conditions, especially for the drying restrictions. And we need to use exactly the same mixture, the same pulp. I don't know if that.
Yeah, so the same pulp, and I guess the same other components for the paper furnishing, I guess.
Yeah, that's it. Mixture. So that's why we say the furnish pulp.
Yeah, I have here another follow-up question that complements what I've just asked. I mean, another question regarding this application of paper mills. Do you think that any additional equipment would be required to do that
actually additional equipment for the mill to do this type of tests? Theoretically, they would only need the end sheet former. They would need to prepare the isotropic sheets for the same weight, that are expected in the paper machine, for the same density, and using similar drying restrictions. Yeah. Actually, I'm sorry. In this case, I'm not being entirely correct. We only need to prepare the isotropic sheets for using the same fish, and prepare it for two drying conditions. So free and restrained dried. Using those extremes, yes, we can try and apply it directly to the pulp, to the paper machine, and without needing additional equipment, except probably something that helps obtain the free dried sheets in a better controlled way. That is the only thing that probably it would be required.
My reflection upon that is that, and maybe you can comment as well, is that if you have that model working as you just explained on the paper mill, you also need to deal with the variations of the paper operating conditions. But basically, would you be able to overcome that by producing several models that will encompass the different paper mill conditions, and therefore do a model of the models, so to speak?
I mean, yeah. So if you are saying that there will be different conditions, what conditions are you saying? So different fiber orientation distribution? you will
For
need
instance,
a model for each fiber orientation distribution. So fiber orientation is really important, and it will change the properties, the properties on MD and CD. So if we know what are the expected main factors, values for at the paper machine. So if it is fiber orientation, the drying restraints, yeah, we can know. But in the meantime, you change the fiber orientation distribution in that given area of the paper machine. You just put the new coefficients regarding the fiber orientation distribution. You put the expected value of drying restraint. So how much did it dry in MD? How much did it dry in CD? Usually in MD you will have draws. So even in the case of draws, we believe that our model can also be applied, because experimental work from previous studies suggests that we get more or less a linear approach till draw values at around 2%. More than 2%, no, it will become non-linear, but at least till 2%, that is usually the values that are used in a paper machine, according to what I know. So yeah, you can.
okay, that's again very interesting topics there and very interesting discussion on that. I'll come back to you, but now a couple more questions to Fábio. I have here a question that'll be interesting to answer the audience. Can you, Fábio, can you tell us the main differences between the formulations that you have used? If you can
Yes,
comment
I
on that.
cannot go in much detail, but the main difference is the photo initiator used, the type of photo initiated used between the formulations and the of quantities.
Okay. And couple of follow-up questions on your work as well. I know there are some results that seems to imply that surface roughness is increasing with higher pickup application. Do you know why is that the case? Do you have an explanation for that?
Mm, I can try to give you one. Well, if we compare between base paper and the commercial paper that has excess surface sizing and where the surface is smoother, the coding application also increased, but not in the same level that increased for the base paper. So I would say it's kind of how do I say it? In fact, that it's potentiated by the already existing surface of the paper. So if I apply a coating layer, I'll have an increase of the surface roughness higher for base paper because it's already more rough than the commercial paper, and this effect is potentiated because of the already existent surface roughness. I would say, it's just an hypothesis. I will have to evaluate that.
Okay, and then another question also, Fábio, a more technical one related to the Kawunger value. Did you also measure the Kawunger value in water vapor transmission?
No, but at least the water vapor transmission is an objective to we want to evaluate that. However, as I said, we still need to, although we already have good results regarding the hydrophobicity provided to vapor, we still want to optimize the coating formulations for improving the gas barrier. As you could see, the values are still a bit low, values that are not worth to take these samples. Because of that, it's not worth to take these samples to evaluate the water barrier transmission at this stage.
Okay, thanks, Fábio, for that.
Thank you.
Now turning back to the essential oil carrier paper and Roberto, we have two questions here that relates to application of your research work. Two questions that can be related to one. One, is your approach suitable for tissue paper? And you think that making paper bags with a nice smell of bio-waste would be also a nice application? So tissue paper and paper bags.
Yes, first one, I do think it's possible, but we couldn't use the same coating method. I mean, because we were using printing paper, then we use bar coating, and there's no bar coating process, as far as I know, regarding tissue. I mean, it's not strong enough to withstand that. But it could be, for instance, tissue paper could be coated with this essential oil carrying starch or another polymer by another means, let's say spraying something that doesn't require paper strength. So it's possible. Also, it can be, as I said, it can be attached to the cellulose itself and make tissue paper with cellulose bound to cyclodextrin. So that's indeed a possibility. And loading it with the essential oil in situ. Yes. So it can be applied to tissue paper indeed. As for this bags with smell, the problem is, if smell is the aim, there are better strategies. This strategy is good for precisely not releasing the compound. If something smells, it means that it's been released. So this cyclodextrin approach was really good from my point of view, because working with terpenic compounds that, when they are with water, tend to evaporate along with it because of their thermodynamic with water, high activity coefficients and everything. And so we needed this kind of complex. But the goal here was precisely not to release the compound, or at least the conclusion is, even if we wanted to provide paper with some smell, we didn't get it, but we got a way to not release the compound. So I would say yes to the first one, and unfortunately no to the second one.
So the follow-up question on that, how you would proceed with your work in order to have a slow release of the essential oils from the paper?
To have a release, but in this slow release, what I would do was like maybe overloading paper with the essential oil, so there's a non-complex excess and a complex part. The excess, most of it is going to be lost upon drying, but then during the following days, there could be a slow release, and then something that remains of paper. That's a hypothesis, but I'm not really confident about that.
Well, something to dig in a bit more. Just a final question before I go back to to Paulo. We talked a lot about essential oils, but I did not hear any comments where these essential oils were coming from. Of course, they're coming from eucalyptus, but where are they coming from? Are they coming from, you are producing yourselves, you're buying them? What is the nature of the material that you have used?
They are purchased. They are supplied by another provider. Yes, I don't know the conditions for the distillation or the extraction, or I just know the composition of the essential oil, that considering that they are more concentrated in light compounds than other essential oil that from eucalyptus that I could find in the literature, I guess that this is like a relatively light fraction, but I didn't produce them.
Okay, so that means that they're not coming from any essential oils production unit in Portugal. This is a provocation question, so the audience can know.
Actually, the provider is a Portuguese company. But
okay, there you go. But good. So thanks for your comment on that. So coming back to Paulo, we have interesting question here also from the audience regarding refining variability. So the question is really how about refining variability and proportioning flow and consistency variability, which has a direct impact on drying conditions. How you expect to tackle this in a real paper machine. So again, talking again on the applicability of your model into real life paper machines.
Okay, it was a very interesting question. Okay, the model is applied to a given mixture, to a given furnace. So that furnace has a pulp that has a given refining that was subjected to a given refining level. So we are considered that to be blocked, that factor. If there is really a variability, and that variability is really important in terms of the refining of the pulp during the process, we will have to prepare to apply it for several batches, or for several, for example, I don't know if the variability will, I don't know if the variability will be noticed after an hour, will be noticed after half an hour or something. But for example, to get samples of that furnace, then get to prepare it for the isotropic conditions, free and restricted, we will get a range of property values for a given drying restraint level. So the drying restraint level will change or something, but in that graph we will have the prediction for that particular new drying restraint level. Okay, and we will need to do this for more than just, so we will do this one time, then we will do this another time. If really the refining variability is really important, and because the model as it is right now, it considers a blocked factor, the furnace. So I don't know if I answered, and there was another part of the question that is the proportionate flow. Okay, again, this will give. Okay, this will follows directly into what is the density of the paper that we are getting, or we intend to get, and especially what is the fiber orientation distribution. So again, we will get you will introduce in the model what is the predicted fiber orientation distribution, And we will get the range of property values for different levels of drying restraints, and depending what is the drying restraint that we will get, we can try to determine to infer what is the value of the property for those particular conditions. I don't know if I was clear, but actually it was a very interesting question.
Yeah, I think very interesting as well. Refining is always a key question.
Yeah.
Having another look into your model and your results, thinking myself another potential application, which probably already thought of, but like to hear your comments. But basically, your tools, instead of being used as a prediction tool on a real life paper machine, because there's these constraints that we're discussing about, could it be used for optimization model for furnish design? Because with this you can do a lot of iterations without a lot of work, I would imagine. Would that be the case?
That is one of the potential applications of this type of methodologies. So you are trying to infer what is going to be your the properties that you will get, and so you will you could get information if you are getting the properties that you want or not, if you are going to have dimensional stability problems or not. So yeah, it could help people to think, okay, maybe we should look to the pulp that we are using. Maybe we should look to the parameters that we are using to get the fiber orientation distribution in the paper machine. Yeah, that's one of the potential applications of this type of methodologies.
Yeah, it seems interesting that it can be used quite easily in having good optimization from that part. So thank you for that as well. Just final question. We talked here a bit about the other speakers about doing applications in tissue. So coming back to your work, do you think that your models, of course, probably different variables, probably not stiffness, but others, could it be used for tissue paper applications? That's a question for Paulo.
Sorry, it was for me. I
So
didn't. Okay, I didn't understand that it was for me. I'm sorry. Okay, so can we use this for tissue?
Yeah, using your methodology framework, could it be used for tissue? Of course, using other variables, probably.
Yeah. Yeah, I mean, you need to prepare isotropic sheets with the same weight and density that you are expecting. In this case, it will be much lower weight. And you will have to use the same pulp. And you will have to introduce then what is the expected levels of fiber orientation and drying restraints. So it will be similar to use, I believe.
Okay, very good. So we're finalizing our time for discussion. So last question for all of you. So if you have 1 minute or less just to comment, my question in general would be, what will be the next steps for your development work based upon your presentation? So starting with Fábio, what do you think will be the next steps for your work?
As I told you, optimizing more the formulation, so we can achieve a coating that can provide excellent, not only excellent either for properties, but also gas barrier properties that could be used for food packaging, for example, and could be applied to a real life situation and be a commercialized product.
Okay, very good. And Roberto, what about your essential oils? What's next?
Yeah, first, I thought up since your last question about how to achieve an effective release in order for it to smell or whatever. I was thinking about precisely release as paraffinic coating with cinnamaldehyde. And I thought, what about if instead of water, it may be not practical under the current coating systems, but what if instead of water, this solvent is less polar, so it has more affinity towards these terpenic compounds, and they are not released during paper drying. So a paraffinic coating could be the way. That can also be useful for this question. And besides studying individual compounds, like picking, like I did for eucalyptus purum, picking limonene, pinene, terpineal, each individual compound, the individual behavior. That would be the next step, I think.
Okay, very interesting and challenging work ahead of you. So Godspeed. And finally, Paulo, from your side, what do you think of the next steps would be for the application of this
Yeah.
model and this?
We are going to apply this model to data retired obtained from the literature, especially data that has draws applied. And we are also currently trying to implement an apparatus that will help us study draws. So that will be the next step.
Okay, very good. Again, thank you, Roberto. Thanks, Fábio. Thank Paulo. I think there was very interesting presentations. Also, very interesting discussion. Very educative for me. I think very interesting for me to know a bit more about this topic that I'm guessing also for the overall audience that are not dealing with these matters on everyday basis. So again, thank you all. Thanks you for the organization for this first day of Tecnicelpa, and thank you for the audience for having the patience and eloquence to listen to us for this last hour of discussions. Okay, thank you guys, and thank you all, and I'll see you tomorrow.
Okay, thank you.
Thank you.
See you.
Thank
See you tomorrow.